Kia ora. Let's look at how we can use Excel to do the graph for us for this 90935 physics standard. So what I've got here is my volume of hot water that I added in my experiment. And over here under temperature, this is the average. I haven't shown all three experimental results for each data point. I've just got the average here. So now that we've got that, we just simply highlight this and we go to insert and we want the chart with the scatter points and we just want the dots. So here is our automatically made graph based on those results. So the first thing we want to do is we do want to put in our axes titles. So we're going to click this and we're going to click on axes titles and we're now going to put in our what these axes actually are. So my x-axis is going to be the volume of hot water added. Be very specific, don't just say hot water. It's the volume of the hot water and it is measured in milliliters, so include your units. And then over here we want to put in, this is the temperature, so it's temperature and it is measured in degrees centigrade. So if you go Alt 0176, that gives you the degree symbol and a capital C for centigrade. And I'll just delete the rest. So we've got now our axes titles. And now we need to put in the proper heading for the graph because temperature was automatically assigned to it, which is incorrect. So we are going to just type in the heading. So graph showing the relationship, because that was the aim of the experiment, between the temperature and the volume of hot water added. A lot of people just say hot water added. We are measuring the volume. And we could say the temperature of the mixed water just to be more accurate. Now that takes up a lot of space, so we can just simply highlight this and go to the home and change the font size. And if I just put a 10 there, you can see it's a lot smaller and now it fits in over there. The next thing I want to do is I want to add in more grid lines, because if I had to measure my rise over run, it would be very difficult to see where the graph cuts through exact vertical and horizontal lines. So I will just close that, go to my little plus tab here, and I'm going to go to grid lines, and I will click on this little arrow, and I want to have the minor horizontal and vertical lines. So you can see I've now got a lot more grid lines. So if I zoom in, you can see that I've got more lines there. And what I forgot to also do is actually add in my best straight line. So I do that by clicking on that plus and putting on the trend line. So again, you can see there are some points where this dotted blue line goes directly between the crossing over point between the 200 milliliters and the 56 degrees centigrade. Here, for example, it doesn't quite go through. So just look very carefully to make sure you've found 2 points where it crosses exactly. So here's another point that's slightly above perhaps, but that point over there goes more directly. So once you've got that, and you can measure now your 2 y-axis points for your rise over your 2 x-axis points for your run, you can actually also click on this trend line and go to more options, and it will ask you if you want to display the equation. So Excel actually does that linear equation for you. So it gives you something like this. Now this will not give you merit or excellence, even though it's a lovely equation. It's because this is just a mathematical equation and we need to turn it into a physics equation. So what we're going to do here is we're going to say, what is our y-axis? Our y-axis is temperature. So what is the symbol for temperature? It is T. And this is why it was so important with the volume for the x-axis, because our x-axis is not hot water. It is what we've measured is the volume in milliliters. So don't say H for hot or W for water. The X over here is actually the volume, which is a symbol of a capital V. So that is our equation, our physics equation, where the 0.1952 is the gradient, and hopefully you've calculated something similar to that using the rise over run, and the 16.66 is the y-cut, in other words, where my straight line crosses the y-axis. Notice that my y-cut is not the same as my temperature of the cold water with no hot water added. They are slightly different. So when you make your equation, it's not where your data point went, that you measured at 0. It is where your best straight line fit crosses the y-axis. So hopefully that shows you how to use the Excel chart to make a straight line graph, how to add an extra grid line so you can work it out yourself what the gradient will be, and then how to work out or see what the y-cut is, and then of course convert that maths equation that was generated into a physics equation. So hopefully that helps. Kia ora.